At first it was extremely nerve-wracking because we had done a bunch of testing beforehand. Everything was working fine. We had updated the database to have the latest questions. It was good to go. It was good to go. Then when you get to the debate, backstage, there's so many things going on. It was exciting and nerve-wracking at the same time. But once things started going, it was really cool to see the actual numbers like move up and down, which meant people were actually using it. It meant that it was actually working. So it was a lot of excitement. It was nice to be in kind of that environment. Like, you know, it felt like almost like show business. Like, it's like if something goes wrong here, we need to fix it somehow. But luckily, nothing went wrong. Actually, it worked out really, really smoothly.
We also have another technological innovation we wanted to spring on you tonight, a QR code. This is a code that you can scan with your smartphone. If you have a QR reader, it will populate your phone with an online survey that will gauge opinion in this hall of our debaters' performances. Those of you watching and in the hall can also access our mobile online poll through the following URL, www.munkdebates.com/vote. Now, if everything I've said in the last 20 seconds sounds like ancient Greek, I salute you for your knowledge of ancient languages, but don't worry, relax, sit back, enjoy the debate, and maybe your tech-savvy seatmates can fill you in on some of our online shenanigans.
So, online shenanigans, that's the way he described it. But really what we were developing was so the challenge was to create a polling application with real-time feedback that would let users kind of see what people were doing as it happened. So what is real-time? In the web, real-time means that you have the ability to basically have the server communicate to the clients and have the clients communicate to the server automatically and at the same time. And that communication can get passed through all the clients that are available or that are connected to the application, so that you can see the results, or not necessarily the results, but any sort of updates as they happen. So that was what we were tasked to do. Now the application, we're going to see a little demo of the application, how it works. This is just a video Mark capture, but the idea here is that you have the administrator panel here, and then you have the actual application on the other side. When the administrator is ready to have a question open or to have the voting open, he will click open, then he will open the voting, and then that automatically tells everybody else that's connected to the application that, you know, we're good to start. Make sure that everybody updates. Now this also plays into the results. So once somebody clicks on a result, everybody that's connected to the application will also be made aware of the updates that happened. Some of you saw this when we were testing it, and it worked out pretty nicely. So in the real debate, we had about 250 people voting, and it was actually really fun and really cool to see the numbers spike up and down. So I'm going to talk about more of the issues we had in terms of testing, but it was really successful. I think Keith and the Munk Debates people were really happy with it. So. Technology. So really the application was built using HTML, JavaScript, CSS. It was a web application, but there was two pieces of technology that really kind of stood out. They were SignalR and KnockoutJS, and that's the two things I'm going to cover in a bit more detail. So SignalR. SignalR is a ASP library that makes it easy to add real-time functionality to your application. And we already talked about what real-time is. So how does this actually work? Well, SignalR provides you a high-level API that lets you code to SignalR, and you don't really have to worry about, you know, using jQuery or using native WebSockets or anything like that. So SignalR abstracts all that complexity out, and it does that by letting you do remote procedural calls. And remote procedural calls are basically the ability to execute JavaScript on the client from the server. So that basically means that if you have a function definition, you can initialize that or call that function via the server. And that's really how the magic happens. Apart from those calls, SignalR also will use WebSockets as its default technology. But if it doesn't find WebSockets, it will gradually degrade to other technologies, and it'll finally end up in long polling. And I'm sure most of you have heard what long polling is. The benefit of WebSockets is that it's a bidirectional communication. Therefore, the connection is open, and it's always open, and it's secure, and the server and the client can communicate bidirectionally. So that's what SignalR works with. But again, it will default to other technologies if those aren't available. SignalR, how did I come across that? I think I saw a demo online. I think it was actually the space shooter demo that I showed you. And it just seemed really cool. Like, it was, video games, so you can't really ignore them. They're pretty cool. And yeah, there was this really cool kind of MMO ship fighting game that was using SignalR technology. And I'd seen a bunch of stuff before from like Mozilla where they did a similar thing with their, also a game. It was something to do with a quest finder or some sort of like MMO questing. They weren't using SignalR, they were using something else. I think they were using WebSockets. And then yeah, SignalR, just because it was part of the Microsoft stack, it got a lot of reference from different podcasts that I listened to, such as Hansel Minutes or things like that. So the other piece of technology we used was KnockoutJS. And KnockoutJS is a JavaScript framework that lets you normalize the development of dynamic UIs by applying the view model design pattern. And that means that normally when you're doing a kind of UI DOM manipulation, you have to rely on something like jQuery. And usually what you end up doing is you end up targeting a specific element in the DOM, and then you can apply jQuery functions to it. What the benefit of this is that by applying a model pattern to this, you don't have to rely on the slow DOM manipulation, and also the data binding is a lot. It's basically taken care of you by the KnockoutJS library. So it makes things like updating values in the UI extremely easy and extremely efficient. So why KnockoutJS? KnockoutJS is a very lightweight library. It doesn't have any dependencies, and it offers you things like declarative binding, automatic UI refresh, dependency tracking, and templating. So that means that because it doesn't have any dependencies, you can use it in conjunction with other libraries. So for the applications, for the Munk Debate application, I actually use it with jQuery. And jQuery, I used it for things like animation, but all my data manipulation, all my UI updates were actually done by KnockoutJS itself. I heard of Knockout about maybe two years ago, and then I saw a talk from Steve Sanderson about a year or so ago, and I thought it was really cool. It made it a lot easier to kind of create those UIs that you see in applications, whereas before, we were working with jQuery to kind of manipulate the DOM, and it just would create a ton of almost like spaghetti code, whereas Knockout just takes a lot away, and it makes it a lot more declarative, and separates the concerns a lot more. So the development. So how did we actually use these two technologies in the development of the application? So KnockoutJS was used to manage the scene, and a scene in the terms of the application is an isolated screen. So when we saw the demo earlier, we saw that we had the intro screen where it said, join us at 7 when the debate will start. That's a scene. And then the other scene on that screen would have been once the questions were open. So for me to toggle between those two, Knockout made it really, really easy to do that, because I could basically bind or have the UI watch for a specific value in the code and automatically take care of the update. I wouldn't have to worry about writing custom code there. It was all determined by the data. So when the data was ready, the UI would automatically update. User interaction, so anything from voting on an answer, so clicking on buttons, or in the admin panel when we were seeing, opening the debate or closing the debate, those are all user interactions. KnockoutJS was also used to kind of update the UI there. And then again, the scene management, the user interaction all works together with the UI updates.
Our real main consideration was, how is it going to look on the mobile device? So we really kind of kept it very, very clean and stripped down to the point where it's essentially, big, bold type to let people know instructional elements, and then the poll right away, and then immediately some indication that there was like results below that, and like a lot of the transitions and kind of the live changing elements were what really kind of popped for people. But really the design was just to house kind of all that activity going on. We really pride ourselves on those little details we do for clients. sometimes, you know, we could just churn it out and then kind of be that assembly line company, but we really don't want to be. And a lot of us have pride in doing those little details that no one really wanted or thought they wanted until they saw it, and then there's just that little extra bit that really makes that site from like it being good to like a great experience. And it's so subtle sometimes that you don't even notice it, but you just have this feeling that something's working or moving in a different way that you'll remember, right? And I think a lot of us want to spend a little bit of time doing that. Yeah.
SignalR was used primarily as my a way to communicate with the server and the clients, and as well as my data access layer. So all of my data goes through SignalR. I don't have to worry about security or it's all encapsulated within SignalR itself. So this is kind of the application flow. So you have many different clients, and those clients can be desktop, they could be cell phones, it could be anything really. And they all talk to SignalR and the hub, and then SignalR communicates to the database. And this is all bidirectional. So if a client requests an update, SignalR will determine whether that update needs to happen across all the clients. If it does, it will then shoot everybody a message and let them know that that update needs to happen. So how does this actually work? So it's going to get a bit technical here. This code is really, really basic. So initially what we're doing is we're bootstrapping the application. So this is what happens when the application first starts. And this is what would happen for every individual client that comes to the website. So what we're doing here is we're declaring the view model, which is right here. We're then starting the SignalR hub, and then we're initializing the client view model. And that includes things like fetching the data itself, initializing the client view model, and then finally applying our bindings to Knockout, which is really what's doing all the heavy lifting. Now, the other type of interaction is the user interaction. And a user can perform two types of actions. They can perform a local client action, which is something that only the local client cares about. So for example, if a client votes on a question, that client now can no longer vote on that question. So that's a local update. But at the same time, when a client votes on that question, that update, the fact that they voted, that count needs to be pushed to all the other clients. So that would be a global action. And the way that actually works, it's pretty straightforward. One of the benefits of using SignalR was the fact that, again, you're abstracting that complexity to a pretty simple API. So what's happening here is we're changing the status of a question. We're changing it to open, for example. So when we saw in the demo earlier, where you're opening a question by clicking on the admin panel, this is what would actually happen. So here we're saying, on the hub, on the server, initialize this method and pass it the question ID and the question status. So what's going to happen here, the local client will connect to SignalR, or the hub will communicate, and the SignalR hub will have a reference to that function, which is what we called, and it will expect the same signature, so it expects an ID and a status. Then SignalR will do its logic, and this could be anything. This is where essentially it's your server code, and all I'm doing here is just I'm updating the status of a question. And at the end here, we're notifying all clients, and we're actually calling an update question status on the client, and we're passing it data as well. And then on the client end, you'd have a method with that same definition or with that same signature, and again, making sure that we're keeping the parameters the same. And then this local JavaScript function will get executed. And this is what I mean when SignalR can execute JavaScript on the client. So this JavaScript here lives on the client, and SignalR initiated the actual execution of that method. So working with SignalR and working with KnockoutJS was a lot of fun. It was actually fun not to necessarily think in Kentico mode for once. It was more application development. And KnockoutJS was really easy to configure and set up. There is a really simple and powerful API, and there's really good documentation. The guy that actually wrote it, Steve Sanderson, I believe his name is, he has a lot of videos, he has a lot of tutorials on his site, and a lot of people are actually using Knockout for a lot of stuff. Some of the negatives, bootstrapping the application was a bit finicky, and what I mean by that is that you want to make the initialization of the application very, very smooth. And most of these frameworks, what ends up happening is you'll start the application, you'll get some like artifact data because the data hasn't loaded yet, and then maybe a second or two later, probably a second, you'll get the UI will render in nicely. So I ended up doing some of my own kind of like best thinking as to how I should bootstrap the application in order to get that smooth transition. So it was a bit of a pain there, and then checking and maintaining state was a bit hard too because we're keeping track of the client local state as well as the global state for different components. I had to kind of make sure that in my mind I was always kind of making sure that I was aware of what the client state was at, and then if the server took precedence, I had to create custom logic to kind of override all those values. SignalR, again, really easy to configure and set up, especially if you have a NuGet. It's a matter of just installing it in Visual Studio. Really simple and powerful API, extremely simple actually. Basically what they offer is several layers of abstraction. They also offer a more in-depth and more complex API if you really want to get into the nitty-gritty. So if you really want to program directly to WebSockets, you have that ability as well. This is supposed to say good documentation. The SignalR documentation is actually really, really good. A lot of tutorials out there, a lot of really, really good resources. Some of the difficulties with SignalR was the actual testing, the load testing. So internally, we tested it with maybe 10, 15 people. But at the time of the debate itself, we had about 200 plus people testing it. The good thing with SignalR is because it's a Microsoft product, it's actually developed with with high loads in mind. So it was never really a concern, but there was always that kind of like hesitation: is this actually going to work? Is this going to? But it ended up going pretty smoothly. After developing this application, it was kind of fun to think about how we can evolve it or what we can do for if we ever deploy this in another project or even for the next debate. So I think it'd be really cool if we had a dedicated screen on the debate stage itself so that people could see the results as the votes are happening. It would probably encourage more people to vote, or at least make them aware that this thing is actually happening. So that'd be kind of cool. And secondly, it'd be really nice if I could go back and refactor a ton of the stuff that's in there. I had about 2.5 weeks to make this thing happen. So there's definitely a lot of shortcuts in there, but it'd be really nice to almost create like a platform where you could, have clients log in and create polls, create questions for those polls, and then serve them up to or host them as they want.
That's it?
That's it for me.